This video is about a very simple topic. This is how to initialize a Node.js project with Typescript and ESLint, together with, of course, Visual Studio Code. So for this video I created an empty project, and it's empty, I mean it has only a couple of files, and these files are the gitignore license readme md, and the name is Alessia. So then in Visual Studio, let's just clone it out, git clone, and clone from GitHub. It shows Alessia 8, my new project, repository. Okay, it was cloned, and open the project, and here you go, the 4 commands. And then the next thing is to initialize the project with npm init. Here I have a guideline which I prepared before this video. Npm init, package name, version, description, a simple project for Node.js with Typescript, entry point dist dash index.js. The reason is this because I'm going to use Typescript, and then the compiled code is going to be put or stored output into the dist folder as distribution. Test command, git repository keywords, Node.js Typescript ESLint author and license MIT. Yes, this is correct. And then let's install dev dependencies, the tools which I used for this project. Actually, these are the main attractions in this video. Npm install D for dev dependencies, Typescript, of course, for the compiler, tsnode for directly executing Typescript application, and types for Node, as well as ESLint, of course. Excellent. So therefore we have these node modules, of course, and package.json, and here in the package.json we have this types node, ESLint, tsnode, and Typescript. So the next step is then initialize the project for Typescript. Actually, just to create a tsconfig.json, and the reason we need that this tsconfig.json because this is used by default the compiler, and the command is npx tsc -- init. That's quite simple. So this is our tsconfig.json. Let's modify a couple of things. The target ES5, maybe we can change it to ES next, and then for the module I'll just keep it as it is. Yes, the root directory is src, quite common for the source file. This is the folder where I'm going to create my files, and the output directory, where is this output? Out dir, yep, is this dist, which I mentioned in the beginning, and then inline source map. I love inline source map. Just in case this is not going to be a web project, at least not at the moment, so but usually I love inline source map for browsers. And then a couple of important why we use TypeScript for static type checking. No implicit any, that's terribly important. Of course, maybe strict null checks, strict function types, no implicit this, terribly important. Use unknown, okay, no unused locals, yes, no unused parameters. I keep it as it is because sometimes the parameters we cannot control, yes, some of the function. And no implicit any, okay, and no implicit returns. That's another very important. And no implicit override. And okay, so more or less these should be okay for now. And then the next step is do the same thing but with npx ESLint --init. That's again very important. Hopefully you can see. Let me just clear the screen. npx ESLint --init. I've watched a couple of videos about this topic, and very often I use that people create tsconfig and ESLint RC JSON files by hand, which I think is not really a great idea. Why not use these official tools to create them? These are, I think that's the best way to create them, and then you will have the option to review all of the possibilities. In the case of npx ESLint --init, just check out what it is going to do. This is a kind of wizard, and it asks you a number of important questions to check syntax and file problem. Yes, exactly, this is what I want to do. What type of modules does your project use? Yes, JavaScript modules, import, export, exactly. And then which framework does your project use? Definitely no React, no Vue, none of these. Does your project use TypeScript? Yes, this is a TypeScript project. Where does your code run? It's going to run in Node. Interesting. It selected browser. But I was pretty sure I selected Node anyhow. And then what format do you want for a config? That is JSON. And then would you like to install them? These ESLint plugins, TypeScript ESLint plugin, and yes, I want to install them. And at the moment, immediately it starts installing them, and here you go. An ESLint, a .ESLint rc.json file was created for us, and then interestingly it selected browser, but maybe I made a mistake, so let me just change it to Node. And then the next thing is, now that we have ESLint rules, I mean the lint rc.json configuration file. So in the rules section, I love to include my rules, which I collected here from my other projects. Let me just copy them here, and I just give you a couple of words how I use them. First of all, this is the explicit function return type. This is terribly important because I hate when a function definition doesn't define what is the return type. If the return type is nothing, then explicitly I want in my code to have the void return type. Otherwise, it should be defined. A number of errors are coming because of this, and by default, interestingly, this is not part of the TypeScript, so we don't have an option to check this. So that's why this is important. This one is terribly important for TypeScript. No explicit module boundary types. This is very similar. And no explicit any, of course. A warning, that is, I mean, when I use the word any explicitly, it's okay, but I want to see a warning, that is because it warns me that something is not really fine in my application. Of course, I love double quotes. I don't want to feel double quotes is a regular programming language delimiter for strings, so I want to use them in JavaScript and TypeScript too. I don't want to see the single quotes, and I don't want to use semicolons. I love this short format. I don't like the extra completely redundant use of semicolons. Completely the language JavaScript and TypeScript are designed to work perfectly fine without semicolons. And then TypeScript, ESLint, bend, ES comment. Okay, that's it. So these are my rules here, and then let's start programming. But before doing that, make sure that we have an extension, and it is called ESLint. I have already installed this ESLint package. Wow, 16 millions download, really a successful project. And then in the settings, just check for ESLint. Always show the ESLint status bar item, so make sure this is checked, and because this is very important in my opinion. And then the next is here in ESLint code action on save. There are two options, all, but the problem with this all fixes all possible problems in the file. This option might take some time. I have a very powerful computer with 2 Xeon processors, but still this is, because of some reason, extremely slow. So for me, these problems, it works however perfectly fine. So these are the settings that I highly recommend for this extension. And therefore we have prepared our application, and let's just start programming. Create a folder, src, as defined in the tsconfig file in the src, and let's just copy first a function, make it m1.ts, Okay, and this simply has a global variable, a module variable, because these are modules, and then it has two functions. Both are exported, and as you can see, both of them has return type definitions. But here this function is a local function, it doesn't have, and immediately when I say missing return type on function, and that's an issue here. So yep, this is not a compilation error but a linting error, a linting warning. This should be avoided. Okay, and the next is another module here, m2.ts, and immediately you can see the error that the string must use double quotes, and I will show a trick here. Let's just save these files. The trick is that in the terminal I can use a command like npx ESLint -fix. Some of the errors, including this double quote thing, can be fixed. Let's check out if it is going to be fixed for us. Yeah, so one problem was found, missing return type, and then of course when you execute ESLint, remember to enter a starting point for the linting, and it automatically checked. So this function, this fixing feature, is very important when you have a code generator. For example, in the case of Angular and also Stencil or Ionic. So some of these frameworks and tools have code generators, and if you don't like the way they generate a code, with many of these issues can be automatically fixed with the ESLint fix. Okay, and the last module is index.ts. index.ts. Okay, so what this application tries to demonstrate, another I've created for this, for a student, for someone who wanted to learn JavaScript and understand how this import work. So we have here a module that are imported the index. This is the M1 is imported. So index imports both M1 and M2. M2 also imports M1. And in both cases, they both import exactly the same functions. And M1 doesn't import anything, so it just exports two functions. So M1 is on the bottom, and both M2 and index are using them. And index TS also uses M2. That is, this is the hierarchy. Index is on top. It uses both of these modules, and also use M2, which is also uses M1. And then the interesting question that this global variable, how many global variables do we have? in this schema? Do we have this global variable separate for the M2 when it was imported, as well as the index, or is it a shared global variable which is accessible via functions? Of course, directly it is not accessible, so it's completely meaningful to export, but with functions, the interesting question if this is the shared modules. That is how many copies of a module is imported, is created when an import statement is used and applied. And that's basically it. A terribly simple function. And when coming to our terminal, let's just npx ts node and then src. src in our case is more than enough because we are on the Alessia, the home, the root folder, and src is the source. And usually if we have an index.ts or an index.js or whatever index, then this application starts running it. Let's check out how it works. It executes them perfectly. At what you can see that this variable, this is a nice demonstration that in an application you can import as many times as you want a module, but that module is in memory only once, and these are only references. So these imports are only references to that module that has been imported, and that import is only done once. So there is no copying of these modules. So that's a demonstration of how it works, and also the demonstration that how to use TS node. And one more thing, that in a package.json, a quite straightforward thing, how to create then a script. We already have a test here, and let's assume we need a start command, and then for that start command just use np ts node and then src. And why is it interesting that here we don't have to enter npx, because this npx is not needed when a script is executed. And how to execute a script? The start script is very special. Usually we run a script with npm run start, again. Yes, the cases that I didn't save it. So npm run start. Yes, it is executed, and then start is a special, so you can leave out the run and you can simply enter npm start. So my friends, this is how it works. And maybe one more thing is that just to give a try to npx tsc. As you see, it generated and compiled all of the source code into the distribution folder. And then when we open a distribution folder, this is the way it is generated. And then This can also be of course executed with regular node. If I just enter node dist, it executed of course a lot quicker because it doesn't need any compilation. So that was it, friends. Take care.